Alright, let's look at the homework 7.3, problem number 10, part B. Alright, so we're going to use the hyperbolic substitution to evaluate the same integral. Alright, so let's do that. Alright, so let's go through this. So substitution is already there, so go through the derivative. So take the derivative of x with respect to, in this case, t. So dx dt is equal to derivative of a hyperbolic sine of t is a hyperbolic cosine of t. Then multiply through by dt to get dx is equal to a hyperbolic cosine of t times dt. Alright, then we can just do substitution. So this is going to be equal to, alright, integral. Alright, so we just type it in, plug it in, a hyperbolic sine, so it gets squared. So we have a squared, hyperbolic sine squared of t, alright, over, alright, then you have, plug in a squared, and the hyperbolic sine squared of t plus a squared, right? Then dx is a cosine, oh actually I forgot the 3/2 power, then a hyperbolic cosine of t dt. Right, so we're gonna simplify this denominator right here, right? Alright, then you have pull out the a squared and raise it to the 3/2 power, so that's going to be a cubed. So this is going to be a cubed, and hyperbolic sine squared plus 1 is hyperbolic cosine squared. Raise it to the 3/2 power, so hyperbolic cosine cubed of t. Alright, then we can cancel a bunch of things. You can see that there's a here, a squared on top, and there's a cube on the bottom. We can cancel that. And then we can cancel hyperbolic cosine here, and we can cancel one of them, so it's going to be squared. Alright, then you can rewrite this guy as, alright, on top, alright, hyperbolic sine, I'm going to write it as hyperbolic cosine squared of t, let's see, minus 1, and divided by, and on the bottom you have hyperbolic cosine squared of t, right, dt. Alright, then I'm going to split this a fraction. So first the fraction is hyperbolic cosine divided by hyperbolic cosine. So it's going to be just 1 minus, alright, 1 over hyperbolic cosine square would be, so it's a reciprocal of hyperbolic cosine square, would be hyperbolic secant squared of t and dt. Right? Then if you take the antiderivative of 1, so that's going to be t, right, minus antiderivative of hyperbolic secant squared of t, and is a hyperbolic tangent of t. And then plus some constant c. Right? So we have that. Then we just have to go back to x. So in order to find that, right, substitution is right here. All right, let's see. Substitution is right here. All right, then we can just divide through by a to get hyperbolic sine of t is equal to x over a. Right, then we can take the inverse hyperbolic sine to get the t is equal to inverse hyperbolic sine of x over a. Right? So we got that. So t is inverse hyperbolic sine of x over a, right, minus, right, so we have to figure out tangent, right, so hyperbolic tangent, right, of t is hyperbolic sine of t over hyperbolic cosine of t, right? Then let's see, so we're gonna write, since we know how to write the hyperbolic sine of t, which is x over a, so I can write the x over a on top. Oh, maybe I'll write it differently. X over a on top, right? Then hyperbolic cosine of t can be rewritten as square root of hyperbolic sine squared, let's see, yeah, hyperbolic sine squared of t plus 1, right? So we know how to do it, so because, oh, sorry, let's see, I put something else, so this was a right there, right? Then this is going to be a square root of, right, hyperbolic sine of t is x over a, then you square that, then you have a plus 1, right? Then to simplify it, we can just simply multiply top and bottom by a, right? But the a is equivalent to square root of a squared, so we get, so cancel those out, so we just get x over square root of, right? So you have a squared on the bottom, a squared on top, cancel out, so you have just x squared. 1 times a squared would be a squared, right? So you have x over square root of x squared plus a squared plus some constant c, right? So that's the answer using hyperbolic substitution. Right, so let's type it in. Right, so we get hyperbolic sine, oops, I have to go back there, hyperbolic sine inverse of x over a minus x over square root of x squared plus 1, right? And oh, sorry, not plus 1, plus c. Oh. X squared plus a squared, right? Plus some constant c, right? So let's submit for testing. All right, it came back and looks like we got part B correctly. All right, that's it. I hope that this was clear.